Perfect. Morning, everyone. This is my talk, why security as a feature will never happen. Hopefully I'm going to be a bit more positive than the title insists, and I promised Steve it wouldn't be too much of a soapbox, but we'll see. So just very briefly, if you haven't met me or heard me talk before, my name's Munro. So currently I head up the cyber threat unit at Santander, basically do all the technical blue teamy stuff and run a team of people who do that. I'm also on the board of Crest. Don't hold that against me. I used to be a director for B-Sides London. I used to be the VP of Spy Labs as well. I'm currently studying a master's at Oxford University into lots of weirdy red teamy stuff, purple teamy stuff, looking at how you can kind of compare one to another. So if you want to talk about that afterwards, come find me. I've got a master by research and some other stuff. I used to be a pen tester, red teamer, and social engineer. So that's my background. I quite often talk at conferences. I like speaking and sharing knowledge. I formerly spoke at Black Hat, 44Con, and a bunch of other conferences as well. I normally talk about red teaming, sometimes technical topics, purple teaming, collaboration strategies, all those kinds of good things, and about beer often as well. So apologies. I'll start with an apology. Sorry, I'm pretty jaded about this, as most of you will be if you've worked in security for a certain amount of time. Some of the things I'm going to discuss today really focus on what the problems are, how we can resolve them, what kind of efforts are out there to do this, and all those kinds of good things. Just firstly, if you look at the OWASP top 10 between 2013 and 2017, you can really see that not much has changed. There's only really a couple of the issues that you see there that have really changed, and that's largely because they've merged some of the other issues as well. So things like cross-site scripting, SQL injection, all these types of basic attacks that have been around since the mid to late 90s are still in existence and still really common in applications. So it's quite frustrating to see that if you work in application security or broadly in security. Pen testers, I know, will still find these kinds of things. And if you look at bug bounties and these types of things where you're still seeing nuanced bugs around these types of areas. So some of the things I'll go through today is what should developers learn, when should developers learn to code securely. So looking at some of the data about when people are starting to learn it, when they could learn it, and all those different things. Where should developers be getting their skills? Where do they get their skills? And a bit of analysis around universities, some of the available courses that you get. And then also going into a bit of blame and talking about different reasons why it's not happening and how we have to change the culture to improve. So when should developers learn how to code securely? I believe strongly that they should learn to code securely when they start learning to code. So it's inherent, and kind of the title of the talk kind of suggests that it is a feature. So just how you learn how to do different kind of features when you develop code, you should be learning security and what security means and how that feeds into what you're doing and how that works. Wanted to put up a slide with a bit of background, and especially the first two, I think people might argue about which came first: cross-site scripting, SQL injection, CGI, all these kinds of different abuses that you saw kind of mid to late 90s. But these were really important steps, and it's kind of crazy that you're still seeing these issues now. I wanted also to kind of shout out for OWASP and the amount of work that they've actually done in this area, and the amount of different frameworks, things like ASVS, the OWASP top 10, and lots of other different projects that have been really useful in being able to give standards to people. So it's kind of a solved problem, really. So kind of baffling. Also wanted to call out, and I've got some data from here as well, the IBM sponsored 2010 paper, which talks about the different costs of different development phases as to when you can, how much it costs, and that it's cheaper kind of conceptually to fix security bugs in the design phase rather than much later on. Moreover, I just wanted to talk as well about how secure coding isn't magic. A lot of people get quite scared when you talk about doing code reviews. Even pen testers who aren't ex-developers, they start thinking about how they're going to review the code, what this means. But a lot of the time you can teach yourself these kinds of techniques later on after learning incorrectly, and then go back and learn the different things like declaring global variables, what the impact is on the code, and how that kind of flows through everything that you should do, and kind of learning how to do it right. But it isn't magic. So when should devs be learning to code securely? Again, I repeat this a lot. There's a few things that I repeat a lot. It's a bit like a Stuart Lee kind of stand-up gig if you've seen him, but not funny. So they should learn to code when they start learning to learn to code securely when they start learning to code. So again, that's really important. I want to talk as well about the concept of security as a feature. So as I mentioned already, security should be something that you learn how to do as implicit in coding. And it should be a concept that's delivered by everyone who teaches people how to learn to code. I believe secure code is correct code. So if you're not coding securely, you're coding incorrectly. So it's as much a feature as functionality of the code and what it does. It needs to be inherently secure. You need to start day one. I've said it a million times. You'll probably hear it lots more times. And security is, I sometimes describe security as an overlay when you talk about an organization. So people come to me and say, I want to learn to hack. I want to learn to hack stuff. And I say, well, do you know how it works? You need to learn how it works first and then understand how it works in order to abuse the different ways that it works. So in that sense, security is an overlay. But in secure coding, it's definitely not. It's implicit in what it is. And it's important and kind of very fundamental to writing code properly. As I mentioned, the IBM paper, which the graph there is taken from, is really useful in terms of providing lots of data and statistics around how expensive it is to fix bugs at different parts of the development life cycle. So as you can see there, if you fix it during design, it's kind of a single unit and it uses that as kind of like a histogram to compare the others. If you fix it during implementation, it's 6.5 times more expensive. During the testing phase, it's 15 times more expensive. And then if you find bugs during maintenance, security bugs in particular during maintenance, it's 100 times more expensive than fixing it in the design phase. This is a really well-known paper. It's been around, I say, since 2010, and it was really seminal in terms of demonstrating that value throughout the different chains. So where should developers be getting security skills? So in order to answer this question, I decided I'd probably need to do a bit of secondary research and look at different data sources. One of the things that I found which was actually really useful was the Stack Overflow surveys that they do. There's a huge participation rates, hundreds of thousands of people, millions over the years have filled in these surveys and done different things. So from that, you can see that 76.5% of people had degrees who responded to that. So obviously Stack Overflow, if you're not familiar with it, is a development community that's online. A lot of people kind of make a career cutting and pasting stuff from there and cobbling it together insecurely. So a lot of the people who responded to the survey, 76.5% had degrees. Of that number, 79.1% of them had computer science degrees. And then 60% of respondents also had some sort of industry certification. So this was really a validation of, when I was looking at these things, am I going to look at the right areas? So looking at academia and then industry certifications in terms of how are people learning and where are they getting their information about, where are they being taught to code. You've also got a good group of people as well, which kind of learn from other people. But most people, the majority, in fact, have got some sort of formal education, whether it be a certification or a degree. So why don't things change? Again, this can be a little bit baffling to people in the industry. You see it go on and on for years and years, and you don't really realise why aren't people getting any better. And I think, it won't be security professionals who fix this. I think we can lobby and we can push in the right direction, but really there's how many developers versus how many security people. There's millions of developers out there writing shitty code, and there's a bunch of security professionals. Probably about 20% of them know what they're talking about, maybe less. I include myself in the don't know what they're talking about column. But it's really important to realise that we need to educate and we need to guide people and we need to lobby and make sure that we're saying the right things and having the right concepts, because people don't know that this is a problem a lot of the time. You know, the first time you show a developer an alert one popping up on a cross-site script or something like that, they don't even know what it is. You talk them through it and it's kind of a mind-blown moment. So it's really important that we as security professionals kind of lobby and make sure that we're front and centre. I think it's a cultural problem, and it is something that isn't instilled early doors when people are learning how to code. So things that don't change also is kind of within organisations. So if you think about SDLC, how many organisations have you seen that don't do any SDLC, or they use a third party that don't, and then they get all the way to the end of the application development cycle, and then they do a pen test, and there's loads of bugs, and then they go back and fix some of them, but not all of them, and they decide what's broken, what isn't. As we saw from the IBM research, it's much cheaper to do this during the design phase. It's kind of weird still that people don't do it. I think largely it's due to lack of knowledge and not having the right kind of mindset towards it, and being able as a business to take a step back and re-architect how you do your whole processes around these things. But they are things that need to be done. Also CISOs, most CISOs I've met, unfortunately, don't really have a clue about secure development. Some do, and some are very good, but the vast majority don't understand what this is and what this means and what the impacts are. And people aren't being taught right first time. Security, also another mantra that I kind of repeat all the time, is everyone's responsibility. So I think everyone needs to consider that they need to be secure. Quite a lot of the time you'll have development teams and there'll be a security champion within the team, and the security champion will be the security guy. So when you end up doing peer review of code, it'll go to the security guy maybe 9 times out of 10, maybe a few times not, and then they'll look at the code and then maybe make a few fixes. There's no guarantee that he or she's really the expert, but then you kind of move on with lots of flaky bugs. So who's to blame? So again, the mantra around, so for those who can't lip read Gary Oldman, it's everyone. So everyone who gets involved in creation of code, creation of security, creation of systems, or just users of those systems is responsible for security. And I think we need to make people aware that they are, and they need to take ownership of that individually, especially if they're making software. So why is software so insecure? So going back to academia, so looking at the amount of people who have qualifications from universities. So I pulled this chart together, and I'll explain it in a second, which is just the top 25 universities in the UK. What I looked at was software engineering. If they had a software engineering undergraduate course, I would include that. If they had a computer science course, I'd include that. So they're the top 25 from the Times 2019 ranking list, I think, plus Abate, because they do security, and I wanted to not slut shame them, but show them on the list as well as a well-known security university. So the first column there is ManSec. So what that means is mandatory security module on the course in any year. So whether they have or don't have a mandatory security course. The second 2 years is whether they have any security on offer, either as an elective or as a mandatory module within the first 2 years. And the third column is secure design. So whether secure design concepts for coding and whether SDLC or any of these kinds of secure coding practices are included either in their syllabi for the coding courses like Java 101, etc., or for standalone modules. So really there was only 3 universities who did that. Holloway should be a yes rather than a question mark, because I rang them up and asked. The 1, 2 and 3 sec is the number of modules that are available throughout the life of the course by those universities. So most universities, with a couple of it, well, with one exception, has 1 module that's available during the life of the course. Some have 2, and virtually none have 3. Well, there's 4 or 5 that have 3 courses. So really this is a big issue, because when people are learning how to do these things, when they're learning how to code, they're not being taught how to do security, and they're not being told how to code securely, moreover. Looking over to the US, I was going to do top 25 in the US, but trying to read their websites and get through the system and everything, it was taking hours and hours and hours, so I just stuck to the top 3. You can see there that also Not a very good record. The courses in the US are slightly different. So you kind of do a generic degree and then you have what they call a concentration. So it's where you do a kind of a major. When you talk about majoring in a subject, it's where you select the vast majority of your modules across the 4 years that they do come from this specialism. So you get a list of modules and you have to do at least a certain number of them to then graduate with a concentration. So none of them have a mandatory one for any kind of computer science in the top 3 universities in the US. So people are coming out of university, top graduates without this kind of information necessarily. Looking as well at industry is probably even worse than academia. If you look at, I just took a random selection of coding courses that are available online or available through different providers. Very few of them actually do it. Notably, Oracle. Oracle, who own Java, have no security course or qualification as part of their development at all, and no modules within them either. So, not very good, but probably not surprising if you've ever done a code review on a Java app or run a Java app on your machine. I'll make those available at the end if people are interested in seeing them. So one of the things that always occurs to me is there's lots of resources out there for secure development. So why aren't people using them? Is it because they don't know? What are those reasons? So I've created a list of some of the kind of really common ones. So OWASP ASVS, this was something created by Dan Cuthbert, and Jim Manico and a few other OWASP guys. It's a really great project. It kind of is, it should be used how people use the OWASP top 10. So there's 0 to level 3. So there's 4 different levels, and it goes through different security checks and validations that you need to do in order to mature your application. So it's really a bit of a journey. The stages, the levels 2 and level 3 focus on secure, a mix of things that can be pen tested or assessed dynamically from the front end of the application, or code best practices at level 3 at the top end there, which is just things that you need to check that you've done. There's also the secure coding guidelines from OWASP as well, which are really handy. There's lots of basic checklists and things like that. So a lot of organizations use these, but not really properly. And again, they're kind of a bit of an afterthought sometimes. There's also lots of secure coding guidelines out there. So I think it was this year NIST released theirs as well, which is a really comprehensive document, really interesting. CIS benchmarks. So CIS is an organization that provides lots of different information about settings on servers and all kinds of different operating systems. So if you're looking to harden a web server, for example, or whatever your application's running on, or whatever, these guys provide a lot of that information. A lot of tools have these built in as well. So things like Nessus and Qualys have these as policies where you can scan against the baseline if you give them credentials or something like that. There's lots of different books on secure development that are available just on Amazon. Training courses, so things like 44Con, Steve will kill me for saying it, but Black Hat and SANS also have these kinds of things available, which are really useful. And angry little men like me as well, who kind of rant about it, and you can ask questions to various people in industry who've got experience in this area. So what can be done? So a lot of the time we need to really focus on moving forward. So things like pressuring organizations and lobbying to do these things. So if you've got a voice within the community, if you've got some profile, it's important to talk about these things to your colleagues, to your peers, to developers in particular, the ones who are going to be consuming these types of things. So make sure you try and do your part to do that. I think grassroots as well. So speaking to universities, certainly one of my roles at Crest is to work with education and research. So I work with some of the universities and talk to them about these things. It's something certainly that comes up quite often. So those grassroots kind of concepts, when people are doing it, if you look at some of the ways people get in, it's very important to talk about those concepts. Professional services providers can do a lot more. So a lot of the time, professional services providers, especially pen test providers, are quite happy to take the money for the 3-day pen test on the app that's really important and kind of just give them a report and disappear. So I think customers need to get better and the providers need to get better at providing services in order to remediate and help stop making these mistakes. Developers don't know what they don't know. So professional services providers should start trying to drive the industry in that direction. And we should learn from each other as well. So make sure that you're not sat in an ivory tower as the only code reviewer in your team. If that's what you do, make sure you share that knowledge with other people and enable them and lift them up like Darth Vader. Above all, Wheaton's law applies. Those who don't know Wheaton's law, it's simple. It's don't be a dick. So just be nice and accept that everyone's got a different level of learning and skill. So almost there. So just the final thoughts really to wrap up. So what can I do? So I think we should all think about what we can do to help with security, the general level of security across the industry, and feel empowered to do so and to have a voice and to call things out that we know are wrong. Security is everyone's responsibility. So I feel strongly about this, that, your nan and your mum and other people, they need to learn these kinds of concepts as well, because no one else is going to be taking responsibility necessarily for their personal security online or when they're using applications. So we need to make sure people are empowered to make good decisions and know that they should be empowered to do that. Also, security is a feature, even though the title of the talk says it's never going to happen. I think it does need to happen, and it's probably the only way that we're going to improve the baseline of security. So I'm happy to be challenged on that. Language creators and SDKs. So when you look at the development tools that you've got, you get lots of highlighting in there when you've got syntactical errors or things like that. If they included security advice in there? There's a couple that provide basics, but I think if they did a better job of saying, hey, you sure you want to declare this variable as a global variable, because it can be accessed from different functions, etc. That's not a good idea. Don't do that. Those kinds of things will help with coaching. Also different tools that are out there, kind of open source, etc., making people aware of them. So I think the owners of the languages need to make them better. If you look at like the car crash that's PHP, for example, there could have been a lot better job done there, and people don't use it so much anymore. But you look at other languages, they've still got these inherent defaults that are kind of shitty. So they need to step up as well. So that's really it in summary. Any questions or challenges or heckles? There's a few open source free tools that are available. They're normally language specific and they're normally a little bit flaky, but there are commercial tools available for this, like Checkmarx, Veracode, HP Fortify, those types of things. They tend to be very expensive and their pricing models are not normally geared towards non-enterprise level people. So I guess just if you search on GitHub for code review tools, things like that, maybe there's other people in the room who can recommend ones that they've used, but they tend to be language specific. So yeah, but there are tools that do basics. Matt?
I think Silicon Valley's got quite a lot to answer for when it comes to like things like failing fast, right? And not doing due diligence. Say you've convinced the organisation that they have to do something. What's kind of like your thoughts, or how would you approach kind of what is enough with regards to security testing up front, that sort of due diligence? Because you could do it and not find anything, or you could just not look in the first place, right? But you pay that cost. What's kind of your thoughts around that?
So in terms of
how much kind of like how much code review, how much design should we really do? When
sure.
is enough, right? You could, a lot of
sure.
money.
I think at the end of the day, it has to come down to categorization of criticality. And in a money-making organization, that means how much money goes through this application? How much is it worth to us as a business? How critical is it? So I think you will always be tied to, you won't code review the brochureware apps, but the ones, if you're a bank, if you're taking financial transactions, you'll want to throw the kitchen sink at it and do a lot more. So I think there's, a wave of things that you can be doing. A lot of the tools out there now are developing like things like isnt and rasp and things like that, which are going to be helpful in the application security space in terms of highlighting vulnerabilities. But again, it becomes a bit of an arms race, or how much you're going to spend on it. So it's really a money conversation, unfortunately. I think the skills are really important as well. So having the right types of people in the team and making sure people are trained, and you're doing things like peer review and checking that the peer reviews are good. So all that kind of good stuff within, sort of secure development lifecycle practices, really. But it's a money question, really, I think. Yep.
Something I've noticed is there's the reliance no idea. And so when I sit down with developers, I'm not a developer, but I review this stuff. And they go, what use that library and how does that work? Explain to me.
Yeah.
That actually works. Most of them won't know.
Yeah.
They go, I just called it in for my function, call it back. And the other thing I noticed as well is if you say to someone, okay, the application, how does it look like on network? Does it look like on the machine? How does it interact with all that?
Yeah.
Explain that bit to me.
Yeah.
And they don't know because they haven't got the knowledge.
Yeah. So, I mean, that comes back to the design process, really. So what you should be talking about ahead of doing these things is really threat models and looking at what it is. I mean, it makes, applications make vulnerability management inherently hard because, normally the people running the vulnerability management programs aren't secure coders and able to write secure code and understand exactly what the output is. So when the developers push back and go, no, it's not broken, it's not a bug, then that conversation becomes very hard if you're not coming from a position of understanding exactly what that bug is and those types of things. So those things are always a challenge, but I think it's about having the right staff and getting to the point where you do the pen test, and the pen tests only find, pen testing should be used as a validation of secure design. It never is, but that's how it should be used in theory. So until that kind of gets fixed, I think that's always going to be a difficult challenge, that they don't know what they're using and how it works. I mean, you see all the time people using like JavaScript libraries that are hosted externally, where they never have any control over changes or bugs that are in there and things like that. And they never notice, and still someone runs a plugin for Burp and goes, oh, did you know these are old? And got cross-site scripts. So yeah, it's a big challenge.
There are tools as well, but they're usually pricey expensive.
Any other questions or comments or heckles?
What do you think regards the threat modeling, who should be responsible as developers? Security, some organizations have a security go-to person in application security plan. So who should be responsible to the architect developer?
It depends on your organization, right? So some people only use third parties. And then if you're talking about things like threat modeling, you would assume or hope that they're going to do the threat modeling for you. If you're developing in-house, I think it depends how you're set up entirely. If you're thinking about threat models, you need to talk to people like pen testers. They probably need to be consulted, or people who've at least understand the threats that are going to be against the application. If you don't understand what the implications of like an XXE are or something like that, or those types of things, then you can't model that threat and create it. So you need to utilize someone who's got knowledge of what the attacks are going to be. What are the things, threat modeling is like, what are the attacks that I'm looking to defend against? What are the things that I'm concerned about at a high level? So, there's frameworks to help, like Stride and Dread and things like that can help you model threats. But certainly you want to use someone technical who understands the attack vectors really well. They don't need to necessarily design it, but they should be consulted. Any other questions, comments? Awesome. Well, thank you very much, guys, for listening. Have a good day. Cheers.